Good day, everybody. And today we're going to build a Solana blog using their Anchor framework. So let's get right into it. So if you haven't found your way over to the Anchor website yet, please do so. There's a lot of great resources there. And what you're going to need is to install these dependencies before we get started. I'm going to assume that you can open up a command prompt and cut and paste all this stuff in. You have to install Rust, Solana, Mocha. I'm going to skip the Mocha part. But essentially, you need this anchor in the CLI. You will need to use Linux. So I run Windows 10, so I use WSL2, Windows Subsystem for Linux 2. And you can verify the anchors on there by checking the version. The version is really important because the API is changing often. Anchor is really, really new, which is why there's not a whole lot of tutorials on there, hence this tutorial. But the API, they're always adding things, changing things. They don't remove things so much as deprecate them and say you shouldn't use that. So this tutorial is effective as of 0.16.1 of Anchor. You can follow the tutorials on the website there, essentially. There's Anchor version, and then start a project is Anchor init. New project name. Now, the good thing to note is you can see I'm in my code folder here. Anchor init is going to give you, is going to make the folder for you. So if I go Anchor init blog tutorial, it's going to make the blog tutorial folder for me. So you don't have to worry about that. So don't, like I did, make a folder to put the folder in because it's going to make folders upon folders upon folders. Just start at your parent folder and it'll take care of the rest for you. So Anchor init, folder name, project name will not only just initialize the whole package for you and make the folder, and away you go. Then the next thing you're going to need to do is go into your file system there and open that in code. And once it's ready, we'll be able to see all the code there. And as you can see, it's still running in the background, but we can see the file structure here, which I'll kind of run through as we go. The app, right now it's blank. Anchor will init it blank for you, but that's where we're going to put our front end, the app part of the app. The other interesting part to note is programs. So in Solana, all the code is called programs. In other blockchains, they're called smart contracts. In Solana, they're called programs. And here's that thing I told you about with the folders upon folders. They put programs / blog tutorial / source / lib in all these folders. So this is what we want to do and take a look at. So your program code and the code that we'll use for making the blog is in this program / app name / source / librs. So librs is where all the magic is going to happen. So got that up and running. Let's take a look at what Anchor gives us by default out of the box. We got this use, so they're importing the Anchor library, which is handy for us. I've got this declare ID. This is going to be our program ID, which is essentially the base 58 encoding of the public key of the program. Don't panic, we'll get to it. I'm not sure how familiar you are with Solana, but we'll explain it all. Then the next part, we have this sort of program block and then a derive accounts block. So I don't know about you, but I find it useful to kind of sketch this stuff out. So as we go along, I'm going to map the parts on there that I find useful to understand. So what we've got kind of done a little bit of preparation for this. So we've got sort of our program in Rust on the Rust side, and we've got two blocks there. We've got something called the program block, which has a function name in it. And we've also got that other block called derive accounts, which was in a separate block there, right? So what is the purpose of this? Well, if you look closely, your public function initialize, which just initializes an account, matches the name, although it's capitalized down here in derive accounts. So the way Anchor works is anytime you've got this method up here called initialize, Anchor enables you to have a macro below that that has a bunch of helper functions bundled into it, and basically helps populate the function. So we've got those two blocks. But you'll notice from the tutorials that there's another block which we will also need, and that is our accounts block. So whereas these top two, this yellow and orange part are kind of part of the functions, the methods, the program part, this blue one down here with the accounts, that third block is the actual account data. That's where all the storage happens. So the top two is where all the processing happens, and the bottom one is where the storage happens. So, and if you go to the tutorials that they've got on the Anchor website, which are somewhat out of date from the API, like this minimal example, for example, no, not the minimal one, because they just have the first two. You need the third one. They've got this third block down here called account, which has a public structure called my account in there. So that's the third one. We can go ahead and kind of copy and paste that into our code, just so we have something there. And now we've got all three blocks. So the blocks in our code now match the blocks in our diagram here. So we're on kind of on the same page here. So now we've got the basic blocks. What do we need to do? Okay, so let's go back to our command line here. We need to go to the blog tutorial, and from here we can run Anchor build. And what will happen is this will build the initial kickoff of the Anchor build process. And so my personal model is build early, build often. You want to make sure that your tool chain setup is good out the gate, everything works. So do Anchor net, do Anchor build, make sure everything flows. But the other interesting thing that this is going to take a while because it's going to compile everything. But the other interesting thing that this will do is populate this target folder. You can see what it says, build target. So it's going to put everything in this target folder right here, including our IDL, which is our interface design language. I wrote this down. Yes, interface description language. Sorry, I always get the acronyms all messed up, but it's an interface description language, which we'll get to in a second. And as well as our keys that identify this program. So up here in this declare ID, remember before I said that is your program ID. Well, that's got to come from somewhere. So when you do Anchor build, it's going to generate the keys for the program, and then you can copy and paste it into that slot. Now I know that Anchor, they're working on some automation processes for doing this. I don't know if it's quite ready yet, but we're going to do it old school by hand, just so you understand the process of what's going on in the background. Once this whole build process is complete, we can do that. What we can go on to is building out our program. So while we're waiting for that to build, initialize. What are we going to initialize? Okay, so let's fix up this account structure a bit. Let's first of all rename it from my account to blog account. And so, this is where our both the blogger identity or the authority to write to the account is going to happen. And we'll also store the latest post there. Like this would be like the equivalent of your status update. So let's, instead of having data, let's do latest post, and you have to do snake case for Rust. And then we'll also do authority, which will be a public key. Public key, perfect. So these are the two values that we're going to save to our blog account. During initialize, what we want to do is set the authority, because when the account is created and all the data is set, you want to be able to set the authority by the creator. So what we can do is this context. We can use that context, and context has a list. Well, that's really handy. Microsoft VS Code's doing my tutorial for me. Context gives us a bunch of options, which is accounts, program ID, and remaining accounts. So I want to set the authority on the account. So I'm going to go to accounts. And what sort of accounts do I have at my options? Well, I don't have anything yet, because remember how I said that these first two blocks, the program block and the derive accounts blocks, they're linked. So I can't do anything in my initialize block, the first one, until I set everything up in the second one, which is why I don't have any options yet there. So we'll just leave that for now and go down here to initialize and populate this a bit. If I want to be able to access this third block, the account, which is the block count, I need to make it available to my method. And the way I do that is I snake case the same name of the account, which is like this. And then the Anchor's got this like info boilerplate stuff, and you put the type of the account it is. It's a blog account. So now you can see what I just wrote is the snake case of this account, because I want to be able to access this account in the initialize method. So Anchor is going to basically glue all that together for us. And so there's a little bit more that we have to link up here. Because it's an initialize function, I need to put this other macro in here called, it's an account macro. And what do we want it to do? We can span multiple lines, no problem. Well, we want it to initialize. And actually, I should pull up the docs for this, because there are some pretty good docs on, where was that? It was in crates. It was like, where was it? Docs RS. Here they are. Okay. So these derived macros are going to do a bunch of things. So the options that you have are all listed here in the docs RS. So we got assigner, mutable, init, zero, has one, seeds, constraints. So we got all these options, and VS Code will help us out of it because these macros. So we're going to use this init macro here because we're creating the account in this step. We're allowing this initialize function to initialize the account. And with init, as you can see, pair must be provided when initializing accounts. So we're going to need a pair. So we said the pair equals, and well, we can't set the pair to the blog account because that blog account is going to store our states. We actually need another entry, which is called the authority, which we already listed down below in the third block. So it's the same one, but putting it here gives the authority, gives our initialize function access to read, change, write authority, depending on how we set it up. And some new features with Anchor is we can call this, we can make it a signer. And the signer means same thing like the info, but it's not linked to any account. Oh yeah, and in Rust you need semicolons at the end of every line, which is fantastic. So the authority, we have to be able to mutate the authority because we're going to be writing to it. Wait a minute. Are we going to be writing to it? Maybe not. But now that we've got authority listed down here, we can use it up here, authority. So we're basically saying who's going to pay to create this account, because every time you create something on Solana, you got to pay for it. It's, you know, fractions of a penny, but you still have to pay for it. And whoever signed this initialize function is going to pay for it. All right. And the last thing we need is some space. So space is an interesting factor. So you always need 8. Dug this out of the docs a while ago. You need 8 for the account discriminator. Account discriminator, the discriminator. So we're also going to need 32 bytes for the public key, right? The public keys are 32 bytes long. And we also need the amount of space that we're going to store our data in this latest post, right? Now, the way we're going to do this is very similar to the memo program, which is basically using a macro. And I'll get to it later. Let's just say we're going to make it make the posts, max 566 characters long. It's not laying long. Not characters, sorry, bytes. That's a difference. That comes from the memo program. If you go to the memo program in the Solana programming library, down here, 566, it says, yeah, it can support a single byte, single byte UTFs up to 566 bytes. So we're going to kind of emulate the memo program a little bit and their strategies, use some of their tactics. And so we'll just use 566 bytes because that's what the program, the memo program also does. Okay, great. So now we've got the space. I don't know why this is, I expected that. What am I missing here? Oh, it's a comma, that's right. Sorry, yeah, because these are all listed out as fields on the struct, not actual, right? Anchor also says we have to put in a system program, which is the program. And this is kind of boilerplate. I'm not fully understanding why we have to do this, but they're saying you have to put a reference to the system program in there for everything to be copacetic. So that is what we'll do. And am I missing something? All right. So essentially we're saying we want to have access to the authority in our initialize function. So we have to put it here in our initialize structs. We don't need access to the latest post when we initialize because we're going to save that for post initialization. We're going to use the authority as the pair to create the blog account. And we're setting the system authority as that. Now, I think let's go ahead and save that for now. Go back to our build. The build, which you can't see because the screen's not big enough yet, is all done. So it says, you know, to deploy this program, you can do that. We're going to do something different. We're going to use Anchor. But now, if we go back to our file folders, you'll see that in deploy, there's this blog tutorial key pair.json, which has our key pair in it. Yay! So we can use that key pair, convert it to base 58 and put it in our declare ID. So let's go ahead and do that. We do that by going back to the command prompt. Let's clear out this stuff. There we go. Okay. All the joys of programming. So what we can do is just copy this and put it in our as our program ID. Yay! Now our program has an ID. Great. Now that those matches, because that other one was just a placeholder. All right. So because we added all this detail, we actually need to put this lifetime in here too, of course, and that will make our errors go away. Okay, great. Great. So now, what have we got so far? If we've got the actual blog account, we've got the authority, which we're going to save to the blog account. We've got the latest post, which we're going to save to the blog account. We are going to do that saving in this initialize structure. And until we put the blog account in the authority, we couldn't access it up here. So now let's see if VS Code lets us, haha, works. So now because we added blog account and authority and even the system program to our initialize struct in the second block, in the first block, we've got access to them, which is fantastic. So now we've got access to the authority. And what is it that we want to do with that? Well, we need to access the key, the authority key, not that key, but this key. Okay, but where are we going to paste it? Well, we want to save that key to the authority down here, right? So we need to access this first, actually. So let's try this. Context accounts dot blog account. Okay. We actually need to grab And anyways, let's call it a blog account, and we'll grab a mutable reference to that so that we have it there. We're going to set this. So we're going to set this authority to the value of that key with a colon, semicolon. Okay. So what we're going to do, did everybody follow what I was doing here? It's starting to get convoluted. So what we're going to do is we're going to take the blog account. I'm going to take a reference to the blog account, which is this whole thing down here. We're going to get set the authority, which is this, to the authorities key, which is the signer. I'm doing it backwards. All right. When initialize is called, the authority for this blog account, the blogger, will have to sign that instruction. Because they signed it, we'll have access to their key, the public key. We're going to set that public key to the authority in the blog account down here. So it does jump around a bit, but hopefully it's kind of clear. All right, so that's the initialize, because we're saying, okay, this account belongs to this key. We know that they have the key pair, which includes the private key, because they signed this instruction. Therefore, we can trust that it's there, and away we go. And I don't think that authority has to be mutable in this struct, because we're not changing authority. We're just reading it. So it has to be readable, which is great. Okay. The next thing we're going to need is a way to update this account that we've just initialized. We're going to need another function. Get public. We're going to call it make a post or make post. And it is also, we're also going to have the same context up here. Context, we can kind of copy and paste that. But instead of being an initialized context, it's going to be something that we don't have yet. So let's get rid of my errors. Instead of being an initialized context, it's going to be another struct. It's going to be a make post in camel case struct, right? And we'll put the info there too, because we're going to need that lifetime info there. So so now up here with our make post function, because now that we've got that context, we can refer to it as make post, right? It's a little confusing sometimes because there's camel case, snake case, lowercase. Okay. So the context is there. We're also going to basically just do the same thing we did up here with the program result as a result. And we'll need the okay results if it's okay. And then we can put stuff here. We put our post detail in there. Okay, great. So, but our make post struct is empty because we haven't put anything in there yet. So what do we want to put in there? Well, we want access to the blog account. So we'll put the same, not blog tutorial, blog account. And that is going to be, it is an account. And we're going to need the info lifetime because we want the info. And it is a type of blog account. Beautiful. And comma this time because it's a field, not a struct. We also need the authority because we want to make sure that the person trying to make the post has the authority to do so. So we're going to check it against the saved authority that we saved in the initialize. So the authority is pub key, beautiful, beautiful, beautiful. No. The authority signed the transaction, so they're a signer. Right. Okay, so the beautiful thing about Anchor is it does all this wiring and glue for us. Am I recording? Okay, good. Like, I hope I didn't pause it. The beautiful thing about Anchor is it does all this wiring for us, serialization, deserialization, so that we don't have to, but we have to use the macros that Anchor gives us in order to do that wiring for us. So a couple things. We want to change the blog account in our make post, so we got to make it mutable. Okay. And we also want to make sure that it has, just in case, has an authority. There we go. And then, what is this? Expected non-vector. Interesting. Right, because I'm missing this part. That's what happens when you do things from scratch. So we've got a second, you know, a second orange block essentially here in our, we're making a second yellow block. So we need a second orange block to populate the yellow block, right? So that's what that is. We want to access the blog account and authority because we're going to change the blog account, and we want to check that it has an authority. And so they have to sign that transaction when it comes time to doing so. Now we can access all the stuff in our make post function, which is fantastic. So we need the context. Yes, actually, yeah, we need context. But essentially, this is where the fun part comes in. We want to pass in the actual post value. And what's it going to be? Well, we're going to make it a Rust vector, which is essentially an array, array of unlimited length, as you could say, in our post. So we want the post to be, and this is kind of where you can peek in. Let's see if I can peek a little bit. This is where you can peek into existing code and ecosystems like this memo program. Is like pretty good inspiration for starting off with a really, really simple program. The Rust code is all there. So we can open up the programming library, memo. So go to the memo folder, go to the program, go to the source. Now go to the processor. You'll see how the memo program works. And what they've done is they're taking a slice of U8s. We're going to take a vector. They're all 8-bit bytes. Anyway, so they've got this. This is how they grab the input, which they're using a U8. They break it out from bytes, and then they've got some arrow handling, and then they post it. Okay, so why don't we just, borrow this inspiration here and do a similar sort of thing over here. But instead of using that, what we need to do is grab our new post and convert our new post from the vector of bytes, essentially an array of bytes. We're going to use either a buffer or a unsigned integer 8 array, and convert that from a vector of U8 into the string slice. But we need to borrow it because we're using a vector instead of a. All right, I don't have the from UTF-8 there. That is, it's a standard string library, so we got to import that to use it. Would have been over there in this as well. See, they've got use standard string from UTF-8. So just missed that. Okay, so now we've got that in there. We can take our vector, convert it from a vector of U8s to a slice of U8s, which is a string slice, which, there's a lot of Rust ease for. We got a string that we can then use in various different places. So, and then we've got some error handling there in case it happens not to be, UTF-8. If it's not valid UTF-8 bytes, it'll throw, because we're not going to save anything that's not just plain UTF-8, which is just text, right? Because we're blogging here, we need to text. So what I'm gonna do though is get rid of all this other stuff because we really don't need it. And we're gonna change memo to post so that our language is a bit clearer. And so now we've got a post. So what this is basically going to do is take that string of bytes that we post, and like a string is just an array of bytes. So a vector is just an unlimited array. So we said the bytes, the new post. We're gonna take the new post and convert it from the array of bytes to a string slice in post. And then we're gonna take that string slice and we're gonna use this message macro to write it to the program log, which is pretty cool. And so we'll see that in action, but let's see if I can pull up an example from my previous dealings of there. So yeah, why don't we just do this? I'll grab this link, post it over here. If you grab this, and you go to any transaction from Solana, if you scroll down, see this program log here, and you can see some of my tests from the other day, a new blog post that shows up there if you use this message macro, not a memo macro, a message macro. So MSG exclamation mark, and then your string slice, it'll post it in there, which is pretty cool because then it shows up and there's a new blog post at this time and this date. Fantastic. So we're going to use that to keep track of all the historical posts that we've had. But I also want to have sort of like my status, you know, my latest post kept in this slot here, which is the latest post, which also is going to be a vector of U8s. Yeah, change that from before. Okay, so we're going to save it there. So how do we do that? Okay, well, you can do it before or after. It doesn't really matter. Might as well just put it in here afterwards. So much like before, up here, we're going to need to just copy a lot of this code, right? This will essentially be the same. We're going to grab a mutable reference to blog account. But this time, instead of setting the authority, we're going to set the, what do we call it? Latest post to new post. They're the same type. They're both, we're passing in a vector of U8s, and we set latest post to a vector of U8s. So they're the same. So we're good to go, which is fantastic. And so there we go. So does that make sense? So essentially, to recap what we just did, anytime you want to make a new method and have your program do something, if you want it to do something with an account, you need to make sure that the field on the account exists. And then you want to enable your function up here to be able to have access to that account info, which is what we do down here. You list, I want them to have access to authority, access to account. Then you have to specify, well, okay, what kind of access and what do you want to do? Do you want it to be mutable? So you got to have the MUT there for mutable. I want blog account to be mutable. Great. And I also want this call to have an authority. So you say, okay, that's included. Authority has to be an assigner on this account, which means that you're authorized to make that post. And once you've done all that, then you can start using it up here in your function call, right? Like your method. And then that'll save everything to the account. And Anchor uses all these macros to wire up all this stuff to make it all happen. So that is essentially, I think, all we've got to do for the program side of things in Anchor. Are there any questions? Looks at chat. Pre-recorded. I'm going to carry on. All right. So now what do we have to do? Well, so we've taken care of the Rust side. Let's see what's next. So now you've got this wonderful Rust program. And one of the neat things that Anchor does for us is, remember that, what did we call it? The interface description language. This goes in between. It's the go-between. For those of you who haven't been exposed to this, it's really neat. it says go between your client and, where's my little arrows here? Your client and the program, right? So normally if you're building in regular Solana, regular Rust, every time your program changes or your interface changes or your types change, you've got to go back over to, and we're going to use JavaScript as the example. You got to go back to the JavaScript and change all of your calls and all of your interfaces. It's like, oh man, it's such a hassle. You're going back and forth every time you want to tweak something or add something or remove something or change something, change the type. So the really neat thing that Anchor does for us, like free out of the box, is it gives us this interface description language of how to access all these program calls. So if we go back to the code, under all these folders, there's something called IDL. And so now we have a blog tutorial interface description language. And right now it says just initialize. And why is that? Because we haven't built anything since we added all the code. So let's go back to the command line and say anchor build again. What anchor build will do is we'll go back to our new Rust code here and rebuild everything. It's going to have the same key, so you don't have to worry about that, but it'll take all this new interface, all the basically, these two functions, initialize and make post, plus all the constraints that we put in here with, the authority that signs it is going to pay for it, and the authority has to be present. And by present, I mean it has to have signed the transaction in order to make a post. And these are the fields on the post. It's going to basically build out that IDL, and that was fast. If we go back to the JSON, that's exactly what we see. So can I split this in half here? Oh, beautiful, beautiful, beautiful. So what we'll see is our instructions are all there. Initialize. So the accounts we need to initialize is we need to say, well, what's the key of the blog account? We need to say who the authority is, and system programs, boilerplate default. If we want to do a make post, we've got to have a blog account pass in the same key as we did the first time, but it doesn't have to be a signer, but the authority has to be there as a signer. Is signer equals true. And then there's the accounts. It'll say the blog account has a latest post and the authority. And if you notice, like this latest post is the camel case equivalent of what was over here in snake case. So Anchor does all the translation and everything for you, so you can use the interface in whatever language you want. You don't have to use Rust, and you don't have to rewrite your code every time you make a change. All you have to do is anchor build, and it builds out a new IDL. And then, as we'll see in a minute when we get to the client side, you can access everything that's in the IDL through your client. And if something changes, then the interface changes and your client automatically changes. So it saves you a lot of manual back and forth. The other thing that we're also not having to do, which Anchor does for us behind the scenes, is all the serialization and deserialization and checking and packing and unpacking, all that stuff you don't have to do, because these macros, with the hashtag, the pound brackets, it does all that for us, which is fantastic. Because if you've ever tried to convert anything in Rust and Solana and back and forth, it's like it's intense. It's a lot of heavy mind work trying to make sure that you've got everything right. With this Anchor, we don't have to do any of that. You just kind of have to understand what these macros are doing behind the scenes so that you know which one to use where. And that comes back to the documentation here, signer, for example, but mostly this. So here are all your attributes, here are all the options that you have available. And if you don't know what they mean, or if they've changed, you pop onto the Discord and talk to the good folks in there, and they'll help you out. They've been a massive help. So now we've got our Rust code is all up to date. That's more or less the end of the program. And we've got an IDL. The second half of this tutorial is essentially wiring this up to the front end. And I'm going to use Svelte and Svelte kit essentially to take this IDL and do the JavaScript side and turn that into a blog. So I'm going to take a break, and we'll do a second half of the video and in the next phase.